Hey, hi, welcome back. So in this section, we are going to do the soldering of our hardware. Okay. And in this specific lecture, we are going to do the soldering of all the components, all the SMD components which are present on the hardware. And in next lecture, I will show you how to do the soldering of all the through-hole components which are present on this hardware. Okay. So let's start with the soldering process now. So first of all, we are going to start with this IC, which is M5-T2-V1, okay? And this particular IC has got a package of LQFP32. And always remember, whenever you solder this kind of package, what you have to do, you have to solder the two opposite pads or the two diagonal pads of the IC. And that actually, it's going to fix the IC on its position on the PCB. And once you are done with that, later you can solder rest of the pads of the IC. Okay, so it doesn't matter what kind of LQFP package it is. Whenever it comes to soldering the LQFP package, first of all you have to fix the IC, okay, which you can do by soldering the two opposite pads or the diagonal pads. And once you are done with that, then you can start with the soldering of rest of the pins of the IC. Okay. Now here the liquid that I am using, it is called as liquid flux, okay, and we generally use this liquid flux during the soldering process. It's because while doing the soldering process, you know, the solder will actually stick to the soldering iron, the tip of the soldering iron, and we actually don't want that to happen, because if that happens, then the thread of the threads will form. Along with that, the bridges will form between the two legs of the IC. And in order to separate out those bridges, or in order to avoid the sticking of solder to the tip of soldering iron, we actually use liquid flux. Now instead of using liquid flux, you can also use solid flux, okay, which you can see in this video in yellow color. So that solid flux is actually cheaper compared to liquid flux. So you can also use the solid flux while doing the soldering process. It's just that in my case, I don't have the isopropyl alcohol to clean the PCB, because you know, when you use a solid flux at that time, lot of mess is going to happen on the PCB, okay, and you know, there will be lot of stickiness on the PCB, and in order to clean that stickiness, we actually use isopropyl alcohol to clean the PCB. But while soldering this particular hardware, I didn't have the isopropyl alcohol. That's the reason I was using the liquid flux to do the soldering of this IC or this particular hardware, okay. Because of that, I'm going to avoid the mess on the PCB, and the PCB will be much more clean and tidy. Now here you just observe how I am soldering the pins of this IC. What you have to do, you just have to take a little solder on the tip of the soldering iron, and later you just have to wipe that tip from the side of all the pins of this IC, and then automatically all the pins will get soldered in very neat and tidy manner. Alright, so till this point we are almost done with the soldering of M5-T2-V1 IC. On some of the pins of this IC, still there are some bridges, so I will remove those bridges later, okay, by using a solder wick or copper wick. And if you see here, now I am actually cleaning the pins of this IC, and for that I am using liquid flux. Generally we use isopropyl alcohol to clean the pins of the IC or to clean the PCB, but I don't have that isopropyl alcohol at this moment. That's the reason I used solder flux to clean the IC. Okay. Alright, so we are done with the soldering of M5-T2-V1 IC now, and now let's solder the decoupling capacitors of M5-T2-V1 IC, which is basically 0.1 microfarad capacitor. Okay, and C9 and C10 are basically 0.1 microfarad capacitor, and C11 it's basically 22 microfarad capacitor, which you already know. Okay, so let's do the soldering of these capacitors now. Alright, so now let's solder the C15 capacitor, which is basically the decoupling capacitor for analog VCC pin of this IC. So let's solder that capacitor now. Alright, so we are done with the C15 capacitor, which was the decoupling capacitor for AVCC pin. Now let's solder the capacitor for reset pin, which is basically 0.1 microfarad capacitor, which is present on the reset pin, which is C14. Now here, while soldering this particular switch, which is user input switch SW1, while soldering this switch, I did one mistake. Always remember, whenever you solder the SMD components, first of all, you have to do the soldering of smaller components like resistor and capacitor. Now here, actually, I am doing the soldering of this particular switch. Because of that, what will happen, the resistors and capacitor which are present around this particular switch, while soldering those resistors and capacitor, I am going to face lot of problem, okay, which you will actually observe when I will do the soldering of resistor and capacitor. So always remember, whenever you do the soldering manually, first of all, you have to do the soldering of smaller components like resistor, capacitor, inductor, or if there are some other components like SMD ICs, first of all, you have to solder those components. And once you are done with that, then only you have to solder the heighted components or the bigger components like this SMD switch. Okay. Now here, while soldering the resistors and capacitor of this user input switch, I didn't face much problem. But while soldering the resistors and capacitor of reset switch, I faced lot of problem. Okay, which you will observe in the video. So always keep in mind, first of all you need to do the soldering of smaller components, and then only you have to do the soldering of bigger components. And that's the reason, why we solder the SMD components first and later we solder the through-hole components, because generally the through-hole components are bigger compared to SMD components. So if we solder the through-hole components first, then those through-hole components are going to create a lot of barrier while doing the soldering of SMD components. That's the reason, first of all, we always solder the SMD components, and once we are done with the soldering of all the SMD components, only then we solder the through-hole components. Okay, so always remember this point. That will actually make your life easy. Otherwise you will face a lot of problem. And through this course, my purpose is to teach you all these points. Okay, these small points actually gives a lot of pain in the real life. So always remember these points. Alright, so now let's do the soldering of all the pull down resistor of 7-segment display driver IC. Okay, prior to that, let's solder the 0 ohm resistor, which are actually for the MISO and MOSI pin, which we have used to control this driver IC. Okay, so once we are done with this soldering of this 0 ohm resistor, later we will solder all the pull down resistors of this 7-segment display driver. Okay. Alright, so we are done with the soldering of all the pull down resistors of 7-segment display driver IC, and now it's time to solder all the current limiting resistors which are used to limit the current which is flowing towards this 7-segment display. Okay, so let's solder these all current limiting resistors now. Alright, so now let's start with the soldering of RGB LED. And always remember, whenever you use any type of RGB LED, it's going to have the polarity. Okay, so while soldering the RGB LED, you have to check which pin is the pin number 1, and accordingly you have to match that particular pin with the notch of the RGB LED. Okay, you can see here there is actually a one white dot on the PCB which actually represents the pin number 1 of RGB LED, and you just have to match the pin number 1 of RGB LED with that white dot, and then everything will be fine. Okay, so let's solder the RGB LED and its current limiting resistors now. Alright, so we are now done with the soldering of RGB LED. Now it's time to solder the decoupling capacitors or the local capacitors of 7-segment display driver IC. Okay, so let's solder this 0.1 microfarad capacitor and 10 microfarad capacitor. Alright, so now let's start with the soldering of 7805 IC. This IC is actually not symmetric, so you don't have to bother about the polarity in this case. Straight away you can put this particular IC on the PCB and you can start with the soldering of this IC and the components which are connected around it. Okay. Alright, so we are done with the soldering of the current limiting resistor of LED D2, whose value was 2 kilo ohms. Now it's time to solder the LED. Okay, but the question comes, which terminal is anode and which terminal is cathode? So in this video I'm going to show you how to identify which one is anode and which one is cathode, because we know that we should connect anode terminal to the positive rail, okay, plus 5 volt, and cathode should be connected to the ground. Okay, so here I am going to show you how with the help of multimeter we can actually identify which one is cathode terminal and which one is anode terminal. So you have to put the multimeter in continuity mode and you need to connect the black terminal of the multimeter to the cathode and red terminal of the multimeter to the anode. So you can randomly connect these two terminals to the LED, and if LED is glowing, it means that the red terminal part is anode and the black terminal part is actually the cathode. Okay, so here the left hand side terminal is actually the cathode, okay, and the right hand side terminal of the LED, it's basically the anode. Okay, and you can observe on the LED the left hand part. Okay, now I have actually altered the polarity, so left hand part is actually bigger on the LED and the right hand part is actually the smaller. Okay, so the smaller part is anode and the bigger part is cathode. So this is how basically you need to identify which one is anode and which one is cathode in case of LED by putting the multimeter in continuity mode. Now here I actually forgot to tell you one important thing about the LED marking. Okay, if you flip the LED, you will see that there is actually a marking on the bottom side. Okay, and it's actually the T marking. So the line which is pointing towards the terminal, it's basically the cathode terminal. Okay, so you can see on the left hand side, it's basically the cathode. Okay, so T line is actually pointing towards that terminal, so that is actually cathode, and the opposite terminal, obviously it will be anode. Okay, so that's actually another trick to identify which one is cathode and which one is anode, and accordingly you can place the LED on the PCB. Alright, so let's do the soldering of LED now. Alright, so we are done with the soldering of decoupling capacitors of the power supply IC. Now let's solder the SS34 diode, which is actually the polarity protection diode of our power supply. So let's solder this diode now. Okay, now here again there will be polarity in the diode. So the 4 lines which you can see on the top side of the diode, that actually indicates the cathode terminal of the diode. Okay, and the opposite terminal, obviously it's going to be the anode terminal. So always remember there will be some marking on the top side of the diode, and based on those marking you have to identify that it's going to be the cathode terminal of the diode and the opposite terminal will be the anode terminal. Okay, so accordingly you have to place the diode on the PCB. And again on the footprint or on the silk screen of the diode, if you see, we have given one bar which actually represents that it's basically the cathode terminal of the diode, and you have to just match the marking which are present on top side of the diode with the marking, silk screen marking, which we have provided for the diode. Okay, so you don't have to do mistake in this case. Alright, so we are done with the soldering of Schottky diode. Now it's time to solder the decoupling capacitors or the local capacitors of the motor driver IC. So let's solder these decoupling capacitors now. Okay, so we are almost done with the soldering of all the SMD components which are present on the hardware. Okay, now we are just left with the power supply jack. Okay, DC female jack. So let's solder this power supply jack now.